The year is 1985. A magnitude 7.3 earthquake rocks the western United States. The epicenter of the quake is near the town of Landers, California, about 125 miles from Los Angeles. People in LA can feel their buildings shake. All told, the earthquake injures more than 9,000 people, kills more than 60 and causes over $366 million in damages. But for all that damage, it could have been so much worse. In addition to the damage in California, the quake also hits pretty hard in a place where there were around 500 times more people. If it had hit at noon when most people are at work or school, instead of 9 p.m. when most everyone was at home, the death toll could have easily been more than 10 times higher. And that's just how one earthquake can turn out far worse than others, depending on a whole lot of factors. But what if we could predict those factors? What if there was some way we could know which earthquakes would be really bad before they happen? We know an earthquake is coming soon to Yellowstone National Park, so let's see if we can answer these questions while unraveling the mysteries of our volcanic legacy. Yellowstone National Park is best known for its geothermal features like Old Faithful. It's also home to more than half of the world's active supervolcanoes. Every 640,000 years or so, the magma chamber beneath the park erupts, spewing ash as far away as Canada and Mexico. While the most recent eruption was 640,000 years ago, scientists think there's a chance it could happen sooner rather than later. And this isn't like your run-of-the-mill volcano. When Mount St. Helens erupted in 1980, it blew out about 540 million cubic feet of material. The 1815 eruption of Mount Tambora in Indonesia sent 3.6 billion cubic feet into the air. Even the 1980 eruption of Mount Pinatubo in the Philippines put out about 3.5 billion cubic feet. But the most violent eruptions of all were the 3 explosions at Yellowstone in the past 2 million years. Each of them unleashed over 250 billion cubic feet of material. These giant eruptions have had major effects on Earth's systems. For example, after the 13600-year-old eruption, there's evidence that temperatures worldwide dropped by as much as 18 degrees Fahrenheit for several years. There are even reports of massive ice sheets forming at tropical latitudes and of mummified plants being found at the Amazon River's headwaters, thousands of miles away from the eruption site. Yellowstone is such a big deal because it's sitting on top of a very special magma chamber. Magma chambers come in all shapes and sizes, but they're essentially just underground lakes of molten rock. They can be found at just about any volcano. But unlike other volcanoes, Yellowstone has a super plump magma chamber. It's about 43 miles long, 25 miles wide, and up to 6 miles deep. It holds up to 500 cubic miles of magma. To put that in perspective, if you spread the magma out evenly across the park, it would cover every square inch of it with over 132 feet of molten rock. That's over twice the height of the tallest building in the world. So what exactly is going on down there? Well, it helps to understand that magma chambers aren't static. Instead, they're dynamic environments that change over time. New magma comes up from the mantle and old magma makes its way up toward the surface. Some of the older magma even becomes part of the continental crust. For example, if you look at the roots of the Rocky Mountains, you can find pieces of that old magma from the Yellowstone hotspot. In fact, this plume of magma from the mantle is still dooming its way up. It's the reason why Yellowstone is still volcanically active today. But over time, the shape of the magma chamber changes too. It grows and shrinks, widens and narrows. And all of this is controlled by the amount of magma inside of it. Right now, the magma chamber under Yellowstone is on the full side. Scientists think it's held about 1,500 cubic miles of magma since 1985. As of right now, researchers are actually pretty sure that it'll erupt sometime between 2034 and 2045. But just because we know an eruption is coming, doesn't mean we can tell how bad it will be. In order to get a better idea, we need to take a step back. Scientists have been able to use computer models to simulate what happened during the 3 super eruptions in the past 2 million years. But they can't just replay these simulations to see what might happen next. They need to know which simulation best fits the data they have. So they've turned to something else, isotopes. Isotope geochemists study the ratios of different atoms within molecules. Most people are familiar with isotopes like carbon-14, which is used in radiocarbon dating. But there are other stable isotopes like nitrogen-15, oxygen-18, and strontium-87. The really cool thing about stable isotopes is that they don't decay. So, once you have them, they're yours forever. Stable isotope ratios can tell us a lot about what's going on inside the Earth. And in the case of Yellowstone, they can show us what kind of magma is bubbling up from the mantle. To learn more about the magma chamber, researchers drilled more than 12,000 feet deep into the ground. They collected samples of steam and gases escaping through the pores of rocks called basalt. Then they analyzed the stable isotope ratios in those samples. The magma chamber's current contents seem to be a mix of new and old magma. And that means scientists need to mix and match different scenarios until they find one that matches the real-world conditions of Yellowstone. One of the biggest challenges in studying Yellowstone is that scientists only have records of the last few hundred years. It's not like they can just pop open a bottle of ancient magma to analyze it. Instead, they have to rely on proxy records like tree rings and sediment layers, which preserve information about the past. For example, in the early 1980s, scientists discovered something odd while drilling at Yellowstone. They found layers of sediment that seemed to have come from an eruption that didn't happen. To solve this mystery, they turned to something completely unrelated: ice cores from Greenland. They compared the layers of sediment at Yellowstone to the layers of ice in the ice core. And what they found was a match. Both showed signs of an eruption around the year 1000. They even matched the signature of a volcano in Chile. The magma chamber under Yellowstone had likely rumbled to life and then settled back down again. It's possible that this magma was responsible for the 13600-year-old eruption. If so, then that means there's a chance that another one could happen sooner rather than later. All of these pieces of evidence have helped scientists build a picture of what might happen during the next super eruption at Yellowstone. They've developed a couple of different scenarios that could play out, and each one could result in a slightly different level of disaster. If the magma chamber continues to fill at its current rate, scientists expect the pressure inside the chamber will increase. Eventually, the pressure will exceed the strength of the surrounding rock, and the magma will start to break through. How quickly it breaks through determines the scale of the eruption. If the break happens slowly, the magma will have time to pool up on the surface and form a lake. This would lead to an eruption similar to those we've seen at places like Mount Vesuvius or Mount St. Helens. It wouldn't be great, but it wouldn't be nearly as bad as a giant explosion. On the other hand, if the magma breaks through quickly, it will shoot up into the air, sending ash all over North America. Some parts of the United States would be covered in ash, making it difficult to breathe and causing widespread crop failure. And of course, no matter what happens, the nearby towns and cities would have to be evacuated. Places like West Yellowstone, Montana, and Jackson, Wyoming would be out of commission for weeks, months, or even years. But let's be real. The fate of a few small towns is the least of our worries here. If the magma breaks through the surface quickly, the ash cloud will block sunlight, leading to global cooling. Depending on how much ash gets into the atmosphere, the average temperature could drop by a few degrees for a couple of years. While a few degrees might not sound like much, it could have serious consequences. For example, during the 1816 eruption of Mount Tambora, there were massive crop failures across the northern hemisphere. Food shortages led to widespread starvation and deaths in places like Switzerland, Russia, and the United States. Yellowstone's eruption would likely cause similar problems, especially in developing countries that rely on rain and regular temperatures to grow food. So, given all of this, you're probably wondering how bad will the next eruption at Yellowstone be? Well, unfortunately, it's impossible to say for sure. The truth is that super eruptions are rare. We only have a few examples from the past 2,000 years to go off of, and none of them are exactly alike. Some scientists think the next eruption will be similar to the ones in the past 1,000 years, which were relatively small. Others think it'll be more like the ones in the past 1,000 years, which were absolutely massive. And then there's the possibility that something completely unexpected will happen. For example, researchers recently identified a new magma chamber underneath the Yellowstone caldera. Its presence could make the next eruption much more dangerous than expected. All of this is to say that we're in uncharted waters. While scientists do their best to prepare for the worst, we may not know the true scale of the disaster until it's already begun. But maybe that won't stop us from learning something new. Maybe this time, we'll finally learn how to survive an apocalyptic eruption. Thanks for watching this episode of CI Show, and thanks to Brilliant for supporting it.